Right. So this is the final tutorial 5. Now we'll come back to replay. So we saw how we can do meta RL and there we can use the inner loop and outer loop, but we can also just improve the inner loop itself. Like we can probably also within the lifetime do some interesting things, even though we already know how to learn and everything. Probably can even speed up the process or make it more efficient. So there's really no catastrophic forgetting or as minimal catastrophic forgetting as possible. Because even after meta RL, you're not guaranteed perfect solutions. If anything helps, we latch onto it and we use it. And so we're going to revisit replay because as we saw, joint training is perfect, right? Like it's going to give you good solutions in the right setting. So we want to explore if it actually makes sense biologically. Because initially we said joint training doesn't make sense. Maybe there is something to it. So as you recall, the problems with joint training was you need all data at once, right? And that just doesn't happen in the natural world. But maybe you could store some data that you're observing now and then use it somehow later, right? Like you see something now, let's say you store some events from now and put them in like a buffer or a memory, and then later when you're learning on the new task, when you update your weights, you take the previous states into account somehow. The question is, does the brain do something like this? This is where we come to the concept of replay, neural replay. So there's this nice observation in mice. So for example, when they have to perform this T-maze task, where you have a T-maze, the mice is left at the end of the leg of the T, and then it has to go towards food, which is on one of the sides, right? When it's doing this task, you can record its place cell activity in the hippocampus. So here what you're seeing is these are different neurons, let's say, this pictorial depiction, but that's fine. Different neurons coding for different points in space. This is place cells, and this is time. And this is basically telling you when they are firing, right? This is basically showing you like a linear trend, like when you go from one place to another, that particular neuron fires. Now, the funny bit is like, let's say you train this mouse in a particular maze, right? Then it goes to sleep. And when it's asleep, if you're still recording, you can see the same kind of firing patterns going on. So these are the same neurons now ordered the same way. This is time, and you can see the same sequence. So like the same places being visited in the same order, sped up because this slope is higher, right? So this like led a lot of people to at least argue that something like replay is probably happening. One could call this dreaming, for example, right? But there are reasons to believe that this is actually useful in consolidating memories, such that the next day the mouse can still remember like where to go and all of that. We have to consolidate those memories. And this kind of replay is also posited to play a role in like mitigating some sort of catastrophic forgetting. How this happens is not particularly super clear, but at least there is a potential mechanism in neural circuit. So replay is thought to help learning by consolidating memories. So over the long term, right, like over days and everything, how that happens in like a short time, like if I show you one task of the other in 20 minutes, that's a different game, but at least we can take some inspiration from the existence of this phenomenon, as I said. So the idea is the agent can store memories in the form of sequences of states, actions, and rewards, and then these memories can be replayed and the agent can learn from them. So you basically interleaved the current data with some replayed data, right? This is a way to train an older task while doing newer tasks. So it might sound like cheating. It's like, oh, are we going to store like full fidelity, like the states and the actions and the rewards? And that's an interesting thing to think about. The answer might be that you don't need to. There's a lot of work asking like, how deep can this replay be? Let's say we are learning an image classification task. You need to actually store the images, and the answer is no. You can literally go store like activations in high level visual cortex, for example. Probably these memories can be stored in extremely compressed formats and be used very efficiently in this process. Unlike what we did with joint training, where you actually need the data in its usual form. So in this tutorial, we're going to play with replay. So the thing is, in the traditional Harlow task, each experiment presents a new pair of objects. There is no need for like remembering what you did in the past, right? It's completely orthogonal, all the tasks to each other. So here we'll modify the Harlow experiment such that the agent should remember which past objects gave reward, and so that will help it like be even faster in like selecting those objects. So you'll explore this new task and see how replay can help in continual learning. Have fun.